All right, number 11, we have another definite integral, but in this case we have a rational function, but we also have a composite function. And so we see this inner portion right there. So first off, I do want to rewrite this so I don't have a fraction, and we'll have 30x times the quantity x squared plus 3 to the negative second power with respect to x. And so this is going to be the inner portion, and so I'm going to let first, really all I want to do is find the indefinite integral, and then we'll come back and apply the definite integral in a second. So this is 30x times the quantity x squared plus 3 to the negative 2 power with respect to x. So let's do this first. So u is going to be x squared plus 3. du is going to be 2x dx. And so dx will equal du over 2x. We're going to substitute there. So keep the 30x. This becomes u to the negative 2. And dx is du over 2x. And this will cancel out to be just 15. So it'll be 15 times the antiderivative of u to the negative 2 du. We'll use the power rule. So add 1 to negative 2, we get negative 1. Divide by negative 1, and we have plus c. I want to simplify this. So 15 over negative 1 is negative 15. And u to the negative first power is just divide by u. And lastly, we are going to back substitute for u. Remember, u was x squared plus 3. So we have negative 15 over x squared plus 3 and plus c. Now, when we go ahead and do the fundamental theorem of calculus here, we're going to plug in 1 and then we're going to plug in 0, but you don't have to worry about the plus c because it's going to cancel out. So we get negative 15 over 1 squared plus 3 minus negative 15 over 0 squared plus 3. Now, a lot of times when we plug in 0, we think, oh, we just don't need to worry about it, it's going to be 0. But when you're using composite functions, that is not the case. So definitely plug in the 0 there. Here we have negative 15 over 4, and then plus 15 over 3. If we simplify that, 15 over 3 is 5. And then 5 is 20 over 4. And so we're left with a positive 5/4.